Okay, today we're going to discuss surface areas of prisms and cylinders, and listed is our content standard and the mathematical practices we'll use on our assignment. Previously, you found the areas of polygons, and today we're going to find lateral areas and surface areas of prisms and find lateral areas and surface areas of cylinders. A lot of new vocabulary: lateral face, lateral edge, base edge, altitude, height, lateral area, axis, composite solid. In a solid figure, faces that are not bases are called lateral faces. Notice the bases, they're parallel to each other. So that's considered the base, whether or not it's setting on the actual base or not. Those that are parallel are the bases, and all these others are called the lateral faces. Lateral faces intersect each other at the lateral edges, which are all parallel and congruent. The lateral faces intersect the base at the base edges. The altitude is a perpendicular segment that joins the planes of the bases. So there's an altitude. It's perpendicular to the segment that joins the planes of the bases. The height is the length of the altitude. Recall that a prism is a polyhedron with two parallel congruent bases and a right prism. The lateral edges are altitudes and the lateral faces are rectangles. In an oblique prism, the lateral edges are not perpendicular to the bases. At least one lateral face is not a rectangle. The lateral area L of a prism is the sum of the areas of the lateral faces. The net at the right shows how to find the lateral area of a prism. So if you were to take this and cut it apart and lay it flat, it shows how to find the lateral area. And we have a formula for that. It's the perimeter, which is the perimeter of the base times the height. The lateral area L of a right prism is L is equal to the perimeter of the base times the height, where h is the height of the prism. So from this point on, you can assume that solids in our text are right solids. If a solid is oblique, it will be clearly stated. We're to find the lateral area of this regular hexagonal prism. The bases are regular hexagons, so the perimeter of one base is 6 sides times 5, or 30 centimeters. So we take the perimeter of the base times the height, and it gives us our lateral area. So the lateral area is 360 square meters. Now something I want you to make a note of: the bases of a right prism are congruent, but the faces are not always congruent. That's important enough. I'm going to say it again because it needs to be in your notes. The bases of a right prism are congruent, but the faces are not always congruent. The surface area of a prism is the sum of the lateral area and the area of the bases. So let's find the lateral area of this regular octagonal prism. So pause the video and then come back and check your work. We've got 8 sides times 3 is 24 times 9, 216 square centimeters. Key concept: surface area of a prism. The surface area, which is represented as S, of a right prism is the lateral area plus 2 times the area of the base. So here we're to find the surface area of the rectangular prism. When I'm working these, I always start finding the pieces parts first. I find the lateral area, then I find the area of the base, and then I put it all together. So the surface area is 360 square centimeters. Time to check your progress. So pause the video and then come back and check your answer. Okay, first of all, here we go. We've got triangular bases. This 12 by 10 is not the base because there's nothing parallel to this 12 by 10. The triangles are parallel, so there are our bases. We need to find the measure of this side. So we take 6 squared plus 8 squared is equal to c squared to find out that this measurement is 10. The area of the bases, 12 times 8 divided by 2, and then there's 2 of them. So then we multiply it by 2. So the area of these both of these bases is 96. The area of this rectangle, 120. These faces are 10 by 10, which are 100. When we add them together, 96 plus 120 plus 200, we get 460 square units. The axis of a cylinder is the segment with endpoints that are centers of the circular basis. If the axis is also an altitude, then the cylinder is a right cylinder. If the axis is not an altitude, then the cylinder is an oblique cylinder. The lateral area of a right cylinder is the area of the curved surface. Like a right prism, the lateral area equals the perimeter of the base times height. Since the base is a circle, the perimeter is the circumference of the circle. So the lateral area is the circumference times the height, or 2 times pi times r times the height. Notice if we were to cut this and lay it out flat, this is what the figure looks like. The surface area of a cylinder is the lateral area plus the area of its bases. So this is the formula we use. Find the lateral area and the surface area of a cylinder and round to the nearest tenth. The lateral area is 2 times pi times r times h. Now if you're given diameter, an alternate formula for the lateral area could be pi times the diameter times h, with pi times diameter as the circumference of the circle. So pi is 14 and the height is 18, so 2 times pi times 14 times 18 is approximately equal to 1,583 4/10. To find the surface area, we simply substitute into our equation. We've already found 2 pi rh, the lateral area, so we substitute it in, and our radius is 14. Using a calculator, it's approximately equal to 2,814 9/10. Okay, time for you to try your hand. We are to find the lateral area and the surface area of the cylinder and round to the nearest tenth. Okay, the lateral area, 2 times pi times radius times height. So 2 times pi times 12 times 20 gives us 1,508 square feet. I substitute that into the formula for the surface area, and the base is 2 times pi times 12 squared. So that's 904 plus 1,508 gives us 2,412 7/10. A soup can is covered with the label shown. What is the radius of the soup can? So now we're going to have to use what we know. We think what formula for a cylinder has radius in it? The most simple is the lateral area. We substitute in what we know, that the height is 8 and the lateral, the L is 15.7 times 8, the lateral area. So now we divide both sides by 8, or 6, well, multiply, and then we're going to divide both sides by 16. And then divide both sides by pi. So the radius is approximately equal to 2 5/10. So the radius of the soup can is about 2.5 inches. Okay, check your progress. This one is a little bit difficult, so try your best to work out the problem and then turn the video back on and I'll give you the answer and a way to find the solution. Did you get 24? Now here's the trick. We're asking for the diameter. So I start with surface area because they give me the surface area. So I know that the surface area is equal to the lateral area plus 2 times the base. So then I have 480 pi is equal to 2 times 8 times pi, or 2 times 8 times pi times the radius plus 2 pi r squared. Now every one of those terms will be divisible by 2 pi. I end up with 240 is equal to 8r plus r squared. Then I think, quadratic equation. I subtract 240 from each side. The factors of a negative 240, the difference is 8. I have a positive 20 and a negative 12. I set them both equal to 0, and 20 ends up negative, so I can't have a negative measurement, so r is equal to 12. And if the radius is 12, then the diameter must be 24. Very good. Okay, you're ready to begin working on the assignment.